Bismillahirrahmanirrahim. Welcome to Physics second year lecture. In the previous lesson, we discussed about the X-rays and their properties. In this lesson, we will discuss about the laser. Laser is the abbreviation of light amplification by stimulated emission of radiation. Laser is a remarkable device that produces an intense and highly parallel beam of coherent light, and the first laser was being fabricated by Neaman in 1960. In order to understand the concept of laser, first of all, we will discuss about the five main definitions which will be used in order to understand the concept of laser. First is the spontaneous absorption. This is the model of an atom. This is the nucleus, and these are the two energy level, or you can say that these are the two shells. This is the energy state E1, and it is the energy state E2. So if an atom is residing in its ground state, so there are two states. E1 is the ground state in which the normally atom resides, and E2 is the excited state. Actually, this is the electron which either reside in the ground state or the excited state, but we say that the atom is either in its ground state or an excited state. So for example, if the electron is revolving in its ground state or normal energy state E1, and a photon whose energy is exactly equal to E2 minus E1, that is equal to the difference of two energy levels E2 and E1, then this atom or this electron will absorb this photon and jumps from energy level E1 to E2. This phenomena is known as spontaneous absorption. So in simple words, we can say that if electron is in its ground or normal state, and a photon whose energy is exactly equal to energy difference of two energy levels, the electron will absorb that photon energy and will jump from lower energy state E1 to a higher energy state E2. This phenomenon is known as spontaneous absorption. Second one is the spontaneous emission. This phenomenon is similar to the Bohr's theory postulate that whenever an electron jumps from higher energy level to a lower energy level, it emits the energy in the form of light. So if an electron is in its excited state, so this is an unstable state, and this electron only resides in the excited state for a time period of 10 raised to the power minus 8 seconds, and it jumps back to its ground state or normal energy state E1 by emitting the energy in the form of photon whose energy is equal to E2 minus E1. This phenomena is known as spontaneous emission. So if an electron is in its excited state, it will stay there for 10 raised to the power minus 8 seconds, and then it jumps back to its ground state E1 and release the energy in the form of photon whose energy is equal to HF equal to E2 minus E1. This is phenomena which is known as spontaneous emission. Then the third phenomena, which is the main phenomena which causes the laser action, that is known as stimulated absorption. What is stimulated absorption? For example, if the electron is in its excited state E2, and it has to stay there for a time period of 10 raised to the power minus 8 seconds. And during this time, if a photon whose energy is equal to HF equal to E2 minus E1, the difference of these two energy levels, then this photon will stimulate or forces the electron to go back to its ground state by emitting, and it emits two photons whose energy is exactly equal and they have same direction. This phenomena is known as stimulated absorption. So understand two main concepts here. Was in the first case, in case of spontaneous absorption, when a photon falls, it absorbs the energy and jumps to higher energy state. But in this case, it is not absorbing this photon. What is the reason? Because this photon will be absorbed if the energy of this photon is equal to the energy difference of two upper energy levels. For example, there is an other energy state. For example, in this case, this is the energy state E3. If the energy of this photon was equal to E3 minus E2, then it will absorb this photon and jumps from E2 to E3. But here in this case, its energy is equal to energy difference of two lower energy level, that is E2 minus E1. So this atom or this electron cannot absorb this photon. So this photon stimulate or forces this electron to go back to its ground state earlier, and it emits two photons of same energy and same direction. This is because as this photon is not being absorbed, this photon just only stimulate this electron to go back to its ground state earlier, and when this electron jumps from E2 to E1, another photon of energy E2 minus E1 is ejected. So these two photons having same energy and same direction are emitted in case of stimulated absorption. So this phenomena is known as stimulated absorption. This is the phenomena due to which the laser action produces. Then another important definition that is known as metastable state. As we know that in case this is E1, this is the ground state in which the electron normally revolves around the nucleus. And E2 is the excited state, that it means that when electron gets energy, it jumps from lower energy state to higher energy state. But in normal excited states, the lifetime of an atom is 10 raised to power minus 8 seconds. But metastable state are also the excited state in which an excited electron is unusually stable. And if electron goes to this metastable state, then it will reside there for a longer period, that is of order of 10 raised to power minus 3 seconds. So it means that if the electron is in metastable state, then it is difficult for it to come out of the excited state because it has to stay there for a longer period. Similarly, it is difficult for an electron to jump into the excited metastable state directly. And the fifth phenomenon, which is important, that is known as population inversion. Population inversion is a state or a situation in which the number of atoms in the excited state E2 is greater than the number of atoms in the ground state or lower energy state E1. Or simply we can say that if the number of electrons or number of atoms in excited state are greater as compared to the number of atoms or electrons in ground state, then this situation is known as population inversion. Now, in order to discuss the laser action and population inversion, we discuss the phenomena. For this, as we know that it is difficult for an atom to directly jump into the metastable state, So we consider three energy states of an atom. This is the ground state E1, this is the metastable state E2, and this is the excited state E3. So first of all, with the help of an optical pumping or a photons whose energy is equal to E3 minus E1 falls on these atoms. So due to the phenomena of induced absorption or stimulated absorption, the atoms will absorb this photon energy and jumps into the excited state E3. As it is the normal excited state, so the atom will reside there or will stay there for a time of 10 raised to power minus 8 seconds and naturally or spontaneously jumps back to the metastable state or E2 state. And they will emit the energy in the form of photon whose energy will be equal to E2 minus E1. Now, this E2 state is the metastable state. So there, the lifetime of an atom will be 10 raised to power minus 3 seconds. So these atoms will stay there for a longer time. So as this process goes on, the population inversion is achieved. This is possible because the lifetime of an atom in excited state is 10 raised to power minus 8 seconds, and the lifetime of an atom in metastable is 10 raised to power minus 3 seconds. So it means that in case of metastable state, the time for incoming of the atoms in metastable state is less as compared to the time for leaving the atoms to the metastable is greater. So this is a simple situation. If there is a room and in 1 second 10 atoms enter and only 2 atoms exit, then it means that the number of atoms in that room will go on increasing. Similar is the case as in, the time for incoming of an atom in the metastable state is less, that is 10 is per minus 8 seconds. So they are entering at a faster rate, and for exiting this metastable state, the time is larger, so they are emitting from this metastable state at a slower rate. So the number of atoms goes on increasing in metastable state, and soon a population inversion is achieved in which the number of atoms in this excited state or metastable state are greater as compared to the number of atoms in the ground state. When this population inversion is achieved, then a photon whose energy is equal to E2 minus E1, that is called the trigger photon, that falls on the atoms, and due to the phenomena of stimulated emission, the atoms goes back to its ground state by emitting two photons of same energy and same direction, and the laser action starts. Initially, there was no E2 minus E1 photon, so initially these atoms will decay spontaneously and produces the photons whose energy equal to E2 minus E1. As you can see that the source of stimulated emission or the source of laser is a photon whose energy is equal to HF equal to E2 minus E1. And the laser photons are also having the same energy or they are the same photons. So it means that the photons are or the laser light is actually the source of itself. So if these photons all go out of the laser, then the laser action will stop. So we need these photons to trigger the laser action. So for this purpose, two mirrors are used. One is completely silvered or completely reflecting, whereas the other mirror is partially silvered or partially transmitting. So when the photons strike this mirror, they are reflected back into the laser and they produces the stimulated emission in other atoms. So this is the phenomena of laser action and population inversion. The next topic is the helium neon laser. Helium neon laser is a common laser which is being used in laboratories. This is a red color laser light which is normally used in laboratories. It consists of a discharge tube which is filled with 85% of helium and 15% of neon gas. In this, helium is the pumping medium and neon is the lasing medium or active medium. So it means that the laser light is actually produced due to neon, whereas helium is the pumping medium, so it actually transfer the atoms of neon from ground state to the excited state. And by chance, the helium and neon have nearly identical metastable state located at 20.61 electron volt and 20.66 electron volt level. So first of all, with the help of high electrical discharge, the electrons of helium atom are excited to the excited state or metastable state of energy 20.61 electron volt. In this laser, the population inversion in neon is achieved by direct collision with the same energy electron of helium atom. As the helium atoms are due to the discharge, they are excited to energy level 20.6 electron volt. As there is a mixture of helium and neon gases, so they will collide with each other. When the helium atom collides with neon atom, they provide their 20.61 excess energy to the neon atom and extra amount of 0.05 electron volt of their kinetic energy, due to which the neon atom jumps from their ground state to the energy state 20.66 electron volt. So the excited helium atom collide with the neon atom, each transferring its 20.61 electron volt energy to an electron in the neon atom along with its 0.05 electron volt of kinetic energy from moving atom. So as a result, the electron in neon atom are raised to the 20.66 electron volt energy state. In this way, a population inversion is obtained in the neon gas relative to the energy level of 18.70 electron volt. As these are the two energy states which have approximately equal energy 20.61 and 20.66. So by colliding the helium atom with the neon atom, they are raised to the 20.66 electron volt. So population inversion is achieved between these two energy levels of 20.66 electron volt and 18.70 electron volt. Then with the help of mirror, the photons are reflected back into the tube and the photons of energy equal to E2 minus E1, that is 20.66 electron volt minus 18.70 electron volt. These photon triggers the laser action and produces the laser whose wavelength is approximately equal to 632.8 nanometer and its energy is equal to 1.96 electron volt, that is equal to 20.66 minus 18.70 electron volt. Here are the some uses of laser. First one, laser beam are used as a surgical tool for welding the detached retina. The heat energy produced is used to weld the detached retina in eye operations. Another application is the narrow intense beam of laser can be used to destroy the localized area or tissues as it is a highly energy or intense beam, so they produces a high amount of heat energy at a localized position which can destroy the living cells. So the tiny organelles with the living cell have been destroyed by using laser to study how the absence of that organelle affect the behavior of cells. So it means that lasers are also used for studying the effects of different cells. So in this process, a particular cell is being destroyed using the laser, and then we study their effects uh, in the absence of these organelles or cells. Another application is finally focus beam of laser has been used to destroy the cancerous and precancerous cells. Again, the same heat energy produced by the laser at a particular point can be used to kill these cancerous and precancerous cells. Another application is with the help of heat produced due to the laser can be used to seal the capillaries and limbs vessels to prevent spread of diseases. Another application, the intense heat produced in the small area by laser beam is also used for drilling tiny holes in the hard material. The precise straightness of the laser beam as laser beam has, is unidirectional and has a precise straightness, so it can be used to line up the equipment especially in the inaccessible location. Then another application is in case of fusion reactions, the potential energy source are inducing fusion reaction. With the help of laser, we can also produce the fusion reaction. Laser can be developed to identify the hidden fingerprints, and it can also be used in telecommunication along with optical fiber. And lastly, another application that is it is used to generate the three-dimensional images of the object in the process called holography. These are the different uses of a laser. Thank you.